Good morning, everyone. Today, we will be discussing a fundamental topic in A-level chemistry related to atoms, molecules, and stoichiometry. This is a crucial area of study, and understanding it thoroughly will provide a strong foundation for more and advanced concepts. Let's get started. Writing and balancing equation. Chemical equation use symbols from the periodic table to represent elements, making them universally understandable. When writing a chemical equation, follow these simple rules. First, verify the formula of each compound. Second, ensure the equations is balanced. The unbalanced reactions is Na2CO3 plus HCl to produce NaCl plus CO2. Let's break down the equations and simplify the process. On the left-hand side, sodium consists of two atoms from Na2CO3. Sodium carbon consists of one atom from Na2CO3. Oxygen is equal to 3 atoms from Na2CO3. Hydrogens consists of 2 atoms from 2HCl. Chlorine consists of 2 atoms from 2HCl. On the right-hand side, sodium consists of 2 atoms from 2 NaCl. Carbon consists of 1 atom from CO2. Oxygen consists of 2 atoms from CO2 plus 1 atom from H2O and is equivalent to 3 atoms. Hydrogens consists of 2 atoms from H2O, and chlorine consists of 2 atoms from 2 NaCl. Step 2, balancing the equation. Sodium already balanced 2 on both sides. Carbon already balanced 1 on both sides. Oxygen, 3 oxygen atoms on each side, 2 from CO2 and 1 from H2O. And hydrogen is 2 hydrogen atoms on both sides from H2O. And chlorine is 2 chlorine atoms on both sides from 2 NaCl. Final balance equation, you might have Na2CO3 plus 2HCl to produce 2 NaCl plus CO2 plus H2O. The additions of water on the right-hand side balances both the hydrogen and oxygen atom. Atom, molecules, and stoichiometry are foundation concepts that set the stage for understanding the behavior of matter and chemical reactions. Model of the atoms. Thomson's model is in a such way plum-pudding model. Rutherford's model is a gold foil experiment and the discovery of the nucleus. Bohr model is energy level or shells around the nucleus, and quantum model is orbital shapes and electron probability distributions. Ionization energy is referred to energy required to remove an electron from an atom of iron. Let's look into the atomic structure. Atomic structure is only proton and neutron have significant mass and that proton carries single positive charges, while the electron carries a single negative charges. Proton and neutron are found in the nucleus of the atom and that electron surround the nucleus. Proton and neutrons are found in the nucleus of the atom and that electron surround the nucleus. Let's look into the table above, the main difference between the three particles A, B, and C is their electric charge, which is determined by the number of electrons compared to proton. Particles A has 11 protons and 10 electrons, so it has a positive charge because it has one more proton than electron. This is a caution. Particle B has 11 protons and 11 electrons, so it is neutral, no charge. And particle C has 11 protons and 12 electrons, so it has a negative charge because it has one more electron than protons, and this is an anion. All three particles are formed of the same element, sodium, but they differ in their charge state. Cation is referred to positive ion, which is referred to particle A. Neutral referred to no charge, which is reflect particle B, and anion is referred to negative ion and reflect particle C. Let's look into the arrangement of electron in atom. As the number of proton in an atom increases, its mass also increases. And after hydrogen, the extra mass comes from neutron in the nucleus. Refer to the table on the left, where we have elements H, He refer to helium, Li refer to lithium, and Be refer to beryllium, and B boron, and C carbon. So adding electrons to form new atom is not simple because electrons fill different orbits, which are regions around the nucleus that can hold a set number of electrons. And these orbits have different shapes and energy level depending on how close or far they are from the nucleus. And the number of protons in an atom's nucleus define the element. However, it is the arrangement of electrons that decide how the element behaves chemically and how it bonds with other elements. For example, metal atoms usually lose electrons to form positive ion, while non-metal tend to gain electron, forming negative ion. Let's look into electron configuration. On the left-hand side is a periodic table, and this table is reflect the electron configurations for various elements such as hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and carbon. And electron configuration refer to the arrangement of electron in an atom orbitals. Electron occupies specific orbital around the nucleus, and their arrangement determines many of an element's chemical properties. The electron configuration follow a set of rules, including the Paul exclusion principle, Kuhn rules, and Aufbau principle to determine the most stable arrangement of electron. Example to find electron configuration for carbon and boron. What is the electron configuration for carbon and boron? First, you need to find the atomic number of the element. The atomic number tells you how many electrons are in a neutral atom. Carbon has an atomic number of 6. Boron has an atomic number of 5. Fill orbitals following the Aufbau principle. Electron fill orbitals from lowest to highest energy, generally represented by the sequence 1s, 2s, 2p, 3s, 3p, and etc. Apply the Paul exclusion principle, and each orbital can hold 2 electrons with opposite spins. And Kuhn's rule, electrons fill degenerate orbitals singly first before pairing. Let's look into carbon. The atomic number for carbon is 6. And step 1, we have to start with the first energy level, 1s. And the first 2 electrons go into the first s orbital. And the first s2, 2 electrons in the first s orbital. Step 2, move to the second energy level, which is 2s. Place the next 2 electrons in the second s orbital. And the 2s2, 2 electrons in the 2s orbital. And step 3, the remaining 2s electron go into the 2p orbital. So 2p2, 2 electrons in the 2p orbital. Thus, the electron configuration for carbon is 1s2, 2s2, and 2p2. So the carbon position in the periodic table is in this stage. Let's look into the boron. Boron atomic number is 5. So the position of boron is here. Okay, step 1, the first 2 electrons go into the first s orbital, which is 1s2. And the step 2, the next 2 electrons go into the second s orbital, which is 2s2. And the step 3, the remaining electron goes into the 2p orbital, is 2p1. Thus, the electron configuration for boron is 1s2, 2s2, and 2p1. So the key point here is energy level is referred to the number in front of the orbital letter, like 1s, 2s, which indicates the energy level. Lower number represent energy level closer to the nucleus. Sublevels is each energy level has sublevel, which is S, P, D, F, that represent different type of orbitals, with S being the lowest energy and F the highest. And electron distribution is referred to electron field orbitals in the order of increasing energy, and each orbital can hold up to 2 electrons. By following these rules, you can determine the electron configuration of any element by starting with its atomic number and filling the orbitals accordingly. The different orbitals have different shapes. Cross sections of these orbitals are shown below. This is S orbital look like. This is P orbital and D orbital. Ionization's energy is the energy required to remove an electron from an atom in its gaseous state. Imagine trying to pull an electron away from an atom. It takes energy to break the attractions between the electron and the atom's nucleus. The higher the ionization energy, the harder it is to. Ionization energy and atomic number, the differences. As the atomic number increases, as you move across the periodic table from left to right, the ionization energy generally increases. This is because the number of protons in the nucleus increases, which create a stronger pull on the electrons, making it harder to remove them. However, as you move down a group column in the periodic table, the ionization energy tends to decrease. And this is because the electrons are further from the nucleus, and they are in higher energy level, so the pull from the nucleus is weaker, and it is easier to remove an electron. As a summary, across a period left to right, ionization energy increases because the nucleus pull electrons stronger. Down a group, top to bottom, ionization energy decreases because the electrons are further away and less tightly held. That's all for today's presentation. And that concludes today's session. And I look forward to seeing you at the next session. Please subscribe to Jom Studylah YouTube channel. Don't forget to turn on notifications so you don't miss any update. Best of luck in your studies and wishing you every success. Thank you for your support.